And now we're up to our final contender, final but not least, Mr. Kurt Ebeling. And the simplified title of his thesis is Design of Diagnostic Gold Nanoparticles for Cancer Detection. And he's advised by Greg DeCrescenzo and Dominique Trudel in Biomedical Engineering.
Test. Pictured here is Judy. She just received terrible news. She's been diagnosed with stage 3 breast cancer. Her chances of survival are only about 50%. Unfortunately, for about 10% of women who receive a breast cancer diagnosis, they fall into this category. This is a big problem because we know cancer, the later we diagnose it, the harder it is to treat, the harder it is to eradicate, because it's so merciless and powerful. There is a dire need to diagnose cancer sooner and more accurately. Currently, there is one test that is used to diagnose cancer. This involves extracting a sample of patient tissue, staining it, as we can see in this image right here, and then incubating it with a solution of antibodies. What are antibodies exactly? They're just a type of a molecule that's able to biologically recognize and attach to a cancer cell. It recognizes a cancer cell from a non-cancer cell. However, the standard way of diagnosing cancer suffers from some drawbacks. One of the main drawbacks that's related to this test is there is non-uniform labeling. What this entails is that sometimes there are cancer antibodies that don't bind to cancer cells. That's a problem. Sometimes there are non-cancer cells that get binded to these antibodies. This is also a problem because this increases the likelihood of a false non-diagnosis, further exacerbating the situation, and just increasing the likelihood that the cancer progresses to a later stage. What do I propose? Or what is the research proposing? Gold nanoparticles. Now you might be thinking of the gold that your really rich grad student significant other bought for you for your Valentine's. No, I'm not talking about that gold, and the vast majority of people here cannot afford gold here. I'm talking about gold that assembled on a microscopic scale appears just like that, in the bottom right image right there. They have amazing, versatile optical properties that can allow us to distinguish and resolve cancer tissue from non-cancer tissue. They also have the versatility to be attached to a wide range of molecules, such as antibodies. This is exactly where my thesis comes in. My goal is to optimize the chemistry of the reaction that is going to graft these antibodies onto the surfaces of gold nanoparticles. I will be employing different optimization techniques in order to increase the yield, increase the likelihood, and then test the accuracy and validity of these gold nanoparticles on cancer tissue. It hopes to be seen, or remains to be seen, if gold nanoparticles will become the new gold standard for future diagnostic tests. I've been waiting to say that line my whole master's. This can only bode well for patients like Judy, progressing and increasing the likelihood that we diagnose cancer sooner, leading to a swifter management of cancer treatment, increasing the likelihood of survival. Thank you.
Thank you, Mr. Ebeling. Great, so it's over for Ebeling? Ebeling. Okay, great. Okay, this concludes he was the last of the 13 participants who dared come to speak to us today, and I really just want to give them a big round of applause for their participation.